This week we'll be looking at a couple of things that might be slowing down your code that you probably don't suspect. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week, I wanted to look at a couple of things that could be slowing down your Python script that you likely don't know about. Some of them may just seem like good coding practices, but as it turns out, there are significant time penalties for them. And some of them are certainly non-intuitive. So we're going to import NumPy as MP. And the first one is the overhead of a function call. It may not seem like it, but actually making function calls in Python can get very expensive. So if you're calling something many times, it's going to add a lot of time to the overall program. Now, I'm not advocating that you don't use functions and just put everything as one big block of code, but I'm advocating that your functions do things like take an array of numbers and operate on that array and return an array. So that function call gets done once versus gets done for each element of that array in a loop. So let's take a look at how that might work. We're going to define a simple function, square, and our docstring is squares, the input, and it's going to return x times x. So that's a pretty simple function. Let's use our time it magic here, and let's write a loop. So let's create some numbers first actually here. We're going to use NumPy random.random, and we'll make a 1,000 element long array here. So for in nums, square in. We're not going to worry about saving the result or anything like that. And if we wait for the time it to return, we see it's about 166 microseconds in this case. So you might think, well, I'm going to use a list comprehension. This is less code. Surely that runs faster. Now, it will actually get a little bit of a time penalty because we're actually appending things to a list that we're not doing in our loop. But let's just see what we get back as a time result anyway. Okay, so 173 microseconds, so very similar to what we had with the explicit loop. Now let's see what happens if we call square with the nums. So we're passing an array, and it's going to operate on that array and return an array. We see now 847 nanoseconds, so not quite a microsecond. So this is 160 to 170 times faster. So all that function call overhead can really add up. We're not doing anything different other than reducing the number of function calls in our program. Another thing that you probably do but may not think about is make sure you use the built-ins. Things like sum instead of making your own sum. But let's take a look at using sum and numpy.sum and why it's important to make sure that you're using the correct data types for each of these. So we're going to time it, sum, a range of 1 million. So this will be 0 to 999,999, and we're going to sum all of those up. So this is using built-in sum. It's using range, which is working with lists. We see about 33 milliseconds. So actually, quite a while there. Let's use time it now with mp.sum. So we're using NumPy sum and mp.arange or array range of 1 million. So this is going to do the same operation. We'll get the same answer, but we're using an array to hold all of those numbers, and we're using NumPy's sum to sum all of those numbers. 1.5 milliseconds, so about 30 or more times faster. You may say, well, I always use numpy.sum. That just makes good sense. Well, does it always make good sense? Let's look at numpy.sum on a range of 1 million. So now we're giving numpy.sum a list. Same values, but it's a list instead of a numpy array. 83 milliseconds. So several times slower than using the built-in sum. So it really makes a difference what data type you're feeding to your functions. So the whole point of this was to just make you think about, are you using lists? Are you using arrays? Are you using dictionaries? Are you using sets? Is it the best data type? And are you using the most efficient mathematical methods you can on that particular data type? Also, to make sure to keep your function calls logical by passing large chunks of data to a function, having the function operate on those and then return, versus having the function called many, many times from a loop and incurring that overhead each time. These may seem like small numbers of milliseconds or microseconds even, but they add up drastically when you're doing things like gridded computation. I hope that you found this useful and that you can speed up your Python scripts. I'll see you on next week's MetPy Monday.